Looks like we're live. Hello everyone and welcome to yet another Azozin session. Let's make a little bit of an announcement and officially start the stream. So, okay, I'm actually typing in the wrong window. Red circle live on Twitch. And what are we doing today on Twitch.tv? So today we're implementing syntax highlighting for my text editor in C. How about that? So https://twitch.tv/Tony, and everyone who wants to be pinged is pinged right now. Who doesn't want to be pinged is not pinged. It's as simple as that. So today we're going to continue developing our text editor. As already mentioned, you can find the source code of this text editor in here. I'm going to copy paste it in the chat for anyone who happened to watch that in a far future on YouTube. It's probably going to be in the description, but I'm not sure. I don't know. We'll see. Yeah, so let's take a look at the text editor itself. So let's go into DED. So that's literally the name of the text editor. The text editor is called DED, which stands for Dramatic Editor, right? So let's actually reveal this entire thing. Let's start the editor. So this is how the editor initially looks like, right? So, and if you start typing, for instance, hello chat, right, so the editor is being dramatic. So we have a camera that is actually trying to center the cursor and stuff like that. Well, as you type, it actually sort of like moves around. It's trying to be a little bit, dramatic. So on the previous stream, I think we implemented the selection, right? So we're developing the text editor from scratch, so we don't even have any selection. And this is how selection looks like. It behaves like a selection, but right now, if I try to delete something, it doesn't really delete this selection, so it's not finished. I said that I'm going to do that off screen, and I didn't do that off screen, right? So maybe we're going to do that on screen, who knows, but only after the main topic of today. And the main topic of today is syntax highlighting, as already mentioned. So I want to be able to just open a C file. Unfortunately, I can't really open a C file, or at least like a shell file, and have some sort of a syntax highlighting, right? So that probably means that we'll have to get rid of that pretentious rainbowish highlighting thingy. So it's not going to be probably part of the text editor in the future, but maybe we're going to highlight the keywords with this rainbowish effect. Who knows, right? So we'll see how it goes. Right, so I think I'm going to start with highlighting the C syntax, and the way we're going to highlight is going to be super simple. We're going to go with a very simple route for now. We're going to only highlight the keywords, right? So if we encounter a particular keyword, for instance, like void is a built-in type, it is a keyword. Okay, so it's pretty cool. Now I can select the things I'm talking about. This is actually very convenient. Right, so if we encounter something like void, we're going to highlight it with some sort of like a color, right? So maybe we're going to also highlight the comments, right? Personally, I kind of like the approach to syntax highlighting that is that is sort of like proposed by the creator of STB libraries, right? So essentially no syntax highlighting except three things. Right, so all of the code, all of the actually executable code is one color, for example, white, if the background is black, right? So then all of the comments are different color, and all of the string literals is the third color, right? So something like that. So you only have three colors, and right, and it's actually kind of like, it's sufficient enough for me personally, but I don't really follow that highlighting scheme is because I'm streaming, and majority of people on the stream are not gonna understand my choice. I actually tried, and a lot of people kind of find it difficult to read for them. I personally don't mind, but yeah, anyway, so this is just like a tangent. So we're gonna go with a simple keyword highlighting for now. Let's go, I suppose. Let's go. Right, so let me open the text editor. Right, so, and what are we going to be doing today? So I want to start with maybe getting rid of the rainbow effect. So it is done with the shaders. And in the shaders, we have the epic shader, right? So a simple epic, and that's the shader that is responsible for the rainbowish color. So we also have another shader that is intended for images, right? But we can't really use that specific shader for the text because the texture, the texture that the text uses to render actually uses only one color channel, right? So essentially, we make an atlas of the glyphs that we're about to render. Right, and we put that atlas in the texture and we pass it to a shader. The thing about that texture is that it only uses one channel, which is red, and the choice of red is completely arbitrary. And the reason why it uses a single channel is because we get that glyph from FreeType, and FreeType gives us this glyph in a grayscale. Essentially, it's not trying to assume any color of the glyph. It just gives you grayscale, and you can do whatever the hell you want with it. Right, so, and to pass it to a shader, I just pick one channel and I say, okay, I'm passing the grayscale information through the red channel. Doesn't really matter. I could have picked red, I could have picked blue. Doesn't matter. Right, and because of that, just using the shader that is responsible for rendering the images is not really sufficient for rendering the text because the text is going to look red. Right. So what I'm thinking is that maybe we're going to have a special shader specifically for rendering text that treats the texture simply differently, right? It treats it differently. It only looks at the red channel and then it just renders it like using only that one channel. Maybe it just extends that red channel to all of the channels to make it white. And on top of that, since we're going to be highlighting things, highlighting is basically coloring different glyphs with different color. Maybe that shader should also take into account the color that we pass in there, right? Because in our simple renderer, right, if we take a look at the simple renderer, so the main function is probably triangle, the thing that renders the triangle. So here we're passing the vertices of the triangle on the 2D space of the screen. Then we pass the colors of the vertices, and then we pass UV coordinates, right? The colors are used for the shaders that can interpret those colors. The UV coordinates are used by the shader that render the texture. So the text shader can actually use both of these parameters, right? So essentially it's going to use UV coordinates to find a specific glyph in the atlas in the texture, and also these colors to multiply the red channel by to color the text with a certain color. Right, so, and I feel like for that we need like a very specific shader, right? So we have shader for, where are all of the shaders? Like shader for color, which allows you to render just, you know, solid shapes, right? So this is the shader that we use to render the cursor, right? So for instance, we have a cursor, which is just a rectangle. This is the shader that we use, just a solid thing. This is also the shader that we use to render the selection, right? Because selection is just a rectangle behind the text. So that's the same shader. Right, and we have an image shader for the images. And epicness is the shader for rendering the text with rainbow stuff. It's just a temporary thing, and we're probably gonna remove it and get rid of it. Right, so what I want to do for now is I want to introduce the shader for text. What's funny is that we have a image for like shader for image, but we don't really use it for anything. Right, so we're probably gonna use it for maybe icons. Or something like that. Maybe when you go to the file browser to pick a file that you want to edit, maybe in front of the files we're going to put the file icon, in front of the folders we're going to put the folder icon and stuff like that. So maybe that's what we can use that shader for, but I'm not really sure. Though I'm not eager to remove that shader yet because it's super simple. That's the entire shader, right? So the thing about the shader is that it just takes UV coordinates, it queries the texture by those UV coordinates, and it just passes it as a fragment. That's it. It's that simple. Doesn't even put any effects on these things. So I can just keep it. Maybe it's going to be useful in the future. We'll see. But anyway, for now, we need a special shader for text, right? A special shader for text, which is going to you know, be like an image shader, except it is going to only take the red color and multiply it by the color that we passed in there, something like that. We will see. So first I need to actually write some code in here. So, all right. Hello, everyone. Welcome. Okay. So let me see. We probably also need to extend the constructor for the simple renderer, right? Because in this specific constructor, we're passing all of these file paths to different shaders. And I think this is something not particularly convenient, right? Because usually what I do, I have a separate array where I associate different values of the enumeration with the file path. Maybe this is precisely what I need to do. So simple renderer.c. Right, so const char. So how should I call that? Maybe shader file paths, right? So an amount of file paths that we're going to have in here is going to be count simple shaders. Then we're going to be using. So for now, just to keep things simple, I'm going to get rid of the text, right? So with each individual value of the shader, we're going to be associating the file paths that we're passing from the main, right? So simple renderer init. So here are all of the file paths in here. Right, for the color, we need to pass this thing. For the image, we need to put this thing. Right, because we're not going to be constructing another simple renderer with different shaders, right? Because of that, there's no point in passing these file paths like that, in my opinion, right? And in the future, we're going to actually have quite a lot of different kinds of shaders in here, and passing all of them for a singleton, if we're using the OOP, you know, terminology, it's kind of like doesn't really make much sense, in my opinion. Right. So these are fragment shader file paths, right? So, and I don't really know how should I call it. So should I call it something like a vert shader file path? And for now, we're going to have only a single vertex shader, right? So only a single one. We're not going to have more than one, but maybe in the future, we're going to have more vertex shaders, right? So for now, the purpose of the vertex shader is to actually apply the camera transformations, right? As you can see, so the camera moves around and it's done in a vertex shader, right? Because we pass like a mesh of everything that we're trying to render, the mesh that includes the selection, the cursor, and all of the quads associated with the glyphs and stuff like that. It's a pretty big mesh, especially if you open a big file, right? And all of the vertices of the mesh are translated and scaled in a vertex shader, and the only thing we pass to that is just like position of the camera and the zoom of the camera, and all of that is automatically calculated on GPU. I was kind of thinking to do that on CPU, right? But maybe it's a good thing to do on GPU, right? Especially if we're gonna have a lot of those things in the future. It's like a special big file. Right, but probably like right now we render literally everything, even if something is outside of the screen. So maybe in the future our renderer should sort of like cut off things that are not visible, but it's not for now yet. All of that can be applied later. Anyway, so let me go to the renderer, simple renderer. Where is the simple renderer initializer? Okay, so here it is, and we're not going to be accepting anything in here. And let's find init. And I'm going to remove this thing as well. Okay, let's try to compile that and follow the compilation errors. Okay, so here we have vertex file path, so vertex shader file path. So it's a constant, right? It is in fact a constant. Okay, so and now we have coded initialization of each and individual hard-coded fragment shader, but now we actually put all of these file paths into an array, which means that these three things could be compressed into a single loop that iterates through all of the shader file paths. We also have to do for dynamic shader reloading, which is going to be super interesting, especially if you start editing the shaders from within the text editor. Right, imagine opening the shader, right, or opening the shader from within the text editor. For instance, like a shader, where is that? I can't see shit in this mist. I think it's a simple epic frag, right, and edit the shader and modify it and hot reload, and it actually changes the behavior and stuff like that. It's almost like shader toy. We're gonna have that as well in the future, right? Trust me, Kappa. Right, so this is literally the shader that actually applies the rainbowish effect, right? But right now, if we modify it and save it, it's not going to do anything. It needs to actually reload the entire application for now. Okay, so anyway, here we just need to do a loop. We need to iterate through all of the shader files in here. Right, so it's going to be for int count simple shaders, right? So this is how many shaders we have. So the body of the shader, has to be this thing, I mean of the loop, right? So, and we need to replace color frag path. Interestingly, so this is the only place where we refer to the file path. I thought we actually refer to more places, but anyway, what we can do is just replace this thing with that, and that should be enough. That should be enough, and we should be able to remove like literally everything in here. Okay, shader for color. Oh yeah, this is what we have to replace in here. We have to replace shader for color with I, right? Because we're iterating each individual shader. Okay, so that's pretty cool. And let's try to recompile the entire thing. And let's see if we didn't break anything. So I'm gonna open, and as you can see, yeah, everything's fine. All right, I can type everything around. Right, so that's pretty cool. Then I can probably open another thing in here. So everything seems to be fine. I didn't break anything. The shaders are loaded correctly. So another thing I probably want to do, I want to do something like static assert, right? And I say that we expect only 3 shaders for now. So this is needed in the future, in the actually near future. When we add more shaders, we want this place to break at compile time to tell me that I need to update this place, right? So the amount of fragment shaders has changed. There we go. So, and let's actually try to recompile this entire thing. Right. Okay. So let me see. Now, this is the moment that I was talking about. I'm about to add another shader, right? So I was doing a little bit of work, so it's easier for me to add more shaders in here. So specifically, I'm adding shader for text, and now this should not compile anymore, right? It should fail in this specific place, right? Right. And so now I have to do something like shader for text, and I have to specify that shader for text. Shaders simple text, right? But if I finish this entire thing, it should not run. Okay, so of course I need to increment the amount of shaders in here. Right, and then when I run the text editor, it should not work, saying that such shader does not exist. Maybe in the future we will make it so if you can't load the shader, it should not crash the whole application, but it only makes sense when we do hot reloading of the shaders, right? So, but not for now. Okay, so let's introduce the simple text frag, right? And let's see what we can do in here. So this is the version 330 core. Right, I don't know why it's doing it like that, but anyway. So we going to accept the uniform of an image, right? It's quite important because it's literally dependent on the images. And then we're gonna accept the UV coordinates. But on top of that, we also need to accept the color, right? So the color and UV coordinates are coming from the vertex shader. Their names are out color and out UV, so this is actually quite important. Okay, so let me make this thing a little bit smaller. And now I'm gonna do the following thing. I'm gonna query the image by UV coordinate. I'm going to take the X, because we only pass the information about the texture in the red channel, already explained why, and we're going to multiply this by a color, right? We're multiplying this by a color. And then we just assign to the fragment color in here. There we go. Okay, that's cool. That is very, very cool. So let's try to recompile this entire thing, even though I don't think it requires a compilation, right? Because it's shader, right? It's a runtime thing, and everything seems to be working fine, right? So we just added a new kind of shader to our renderer, and now we can just try to use that shader. So how we're going to be using all of that? So where do we render the editor, right? So editor render. Actually, something like this, editor render. Now, so for Epic, and this is where I want to change the shader, right? So I want to change the shader to for text. But the question is, where do we pass the color of the shader, right? So this is where we render each individual text, right? So let me see. Log or Lug, I don't know how to pronounce your nickname, subscribed with Twitch Prime for 5 months. Thank you, and welcome back to our epic OpenGL club. All right, so let me find this thing. And what function do we use to pass information there? Okay, so we use simple image rect. Okay, that's cool. Right, simple image rect. And if I go to the simple renderer, simple image rect actually doesn't really pass any color in there. So essentially, instead of color, it's using like 0000. Right, so maybe one of the things that we have to pass in there is the color, right? That would make sense to me, I think. Right, let's actually put it like this. Yeah, so also I'm going to go to the header, right? So this is going to be the renderer. And vec for FC, right? Vec for FC. So let's actually go and recompile everything. Okay, so here, as you can see, it's starting to complain. So here we have to pass the color. But the question is, should we pass the color here as well? So this function becomes a little bit overloaded, right? Because I use it for two purposes. I use it to render the text and also to compute the size of the text. So this could be a problem in the future. Maybe I should actually do something that John does in Simp, right? Essentially have two functions, prepare text and render prepare text. So prepare text, if I understood correctly, just renders the text on CPU into a texture and just uploads the texture to the GPU, basically preparing it, right? But as soon as you prepare it, you also given the metrics of the final text that you're about to render, the width, the height, and you can sort of, before actually rendering it, you can kind of position it, right? And then as soon as you decided where you're going to put all of that, you can say, okay, render the prepared text there, which is actually kind of cool paradigm, right? So essentially, you split the rendering of the text into two phases. First, prepare it and measure how much space it's gonna take and like what's the shape of it and stuff like that. And then once you're ready and once you positioned everything, you can say, okay, render that. That's kind of an interesting paradigm. I really like it. And when I worked with Simp, it actually worked really great. So in majority of situations, you really want to split that into like 2 steps, if you know what I mean. You kind of want to do that. And interesting enough, like sometimes if you don't want to render, you can never render it. If you just want to see the size of the texture, you can just prepare it, measure its size, and then just forget about it, right? So that's totally fine as well. So maybe in the future I'm gonna do a similar thing, but for now I don't know. It's just something to keep at the back of my head. Right, so here I'm gonna pass the color, right? And the reason why I was talking about all that is because it's not, the color here is not gonna make sense for functions that just measure the size of the text, right? So just like doesn't really make sense, but it's just something that we have right now. But of course we're gonna fix that later. Okay, so now we have to go through all of the places and replace the calls, but even before that, we have to put this thing in here. So here is the caller. There's the caller. Okay, so let's actually go through all of these things. So we don't really render anything. So here I can just pass something like this. If the language supported like default parameters, default value for the parameters, it would have been a little bit easier, right? I would have not have to go through all of that stuff, but it is what it is. And it isn't what it isn't. Okay, so this is a file browser, right? So I'm not gonna mess with the file browser right now. I'm gonna use the Epic shader for the file browser for now. Later we'll get back to the file browser, right? So here we're talking about the text renderer. So here we're just positioning the selection and stuff like that. So here I'm gonna just use 0. I'm just using 0. And another one in here, we're going to be using 1. Right, vec for fs, we're using 1. Alrighty, and that's it. Okay, so that should work. So now, if I run the thing, right, so file browser is rainbowish, but the text in the text editor should be white, and it is in fact white. So we just have a regular text editor now, nothing particularly special, right? But we have both, right? So we have a rainbowish effect, and we have just a regular thingy, which actually doesn't really look that bad. It kind of looks stylish, if you know what I mean. Right, so I kind of like how it looks like. Right, so and to sort of verify that we can actually render the text with different colors, let's actually do the following thing. Let me go to the text editor, and essentially, depending on the line, right, so if the line is divisible by 2, we're gonna use the red color, right, otherwise we're gonna use the white color, right, something like this, you know. So first line is going to be what? It's divisible by 2, so that means it's going to be red. First line is going to be red, then the second one white, red, white, red, white, red, white. Right, just to test things out, right? To confirm that we can actually render text with different colors, but using the same shader, right? So the shader should support this kind of stuff. Okay, red text, and then white, then red, white, red, white. So we can try to open some other things, right? For example, license. And as you can see, the even lines are red, the odd lines are white, right? So that works. So that already gives us the capability of like rendering certain words with different colors, right? So the shader already kind of supports that. Which is kind of cool in my opinion. All right, so which is kind of cool. So that's precisely what we're going for. Right, but for now I'm gonna remove that. Right, and this kind of bothers me. So maybe I should actually separate this function into 2 functions, right? So render line and measure line, like how much space is going to take, because it's kind of like getting out of hands. And as I extend this function, it's gonna get more and more parameters. So yeah, we'll see. We'll see. We'll see. We'll see. We'll see. So the question is, The question is, we probably want to just render certain keywords, right? So a certain keyword should be rendered like with a different color. Maybe I should start with a single keyword, right? With a single keyword and see how I can implement the algorithm that can render a single keyword. But unfortunately, I think I want to make a small break. Yeah, I think I want to make a small break. So I'm gonna do that after a small break. I'm sorry. Right. All right. So I really want to separate this function into two, right? Because it's kind of bothers me. Right. So because at some point the amount of arguments here is gonna grow like uncontrollably. So the question is, how should I call such function? So this one render line, and I suppose this is more of a like measure. Let's call it measure line. So we'll have to provide the position, but we don't have to provide the render, and we don't have to provide the color because like we're not rendering anything. So we just measure this specific thing. But here we're not have to provide the render, but we have to provide the color because we're actually rendering this entire thing. Yep. So where is that? Where is that thing? So let's put it in here. And interestingly enough, the code is kind of similar, except we're simply not rendering. As I already mentioned, we're just like updating the positions and stuff like that. So when in here, we don't have to accept the render. And since we don't accept it anymore, we don't have to check whether we want to render or something. So there is a little bit of duplication, but it's kind of difficult to get rid of such duplication. Yeah. So let's actually go to the compilation errors and hopefully update everything. So there's a couple of places here and there. Right, so since this is a false, we're not rendering, we're measuring. So this is measure, and I'll have to remove this thing. So what's the other thing in here? So it's not really, giving me enough useful information. So here we are rendering, in fact, right? So here we're rendering, but we're rendering with the Epic shader, which doesn't really care about the color because it provides the color itself. So I can just like use it like that. Right. So what's the other thing? Here we are in the editor. And here we're literally measuring, right? So we're literally measuring. So this is another measure. What was the other measure? Oh, this is for the selection in the file browser, right? And in here, we don't even have to provide the color anymore, right? We do not provide the color. What's the other thing? Okay, so here is the rendering. And here we provide the white color, right? So that's the actual rendering of the text. So what's the other things? So here we have width and height, which I'm not really sure why do we use them for. So this is for positioning things appropriately. So which means that we don't really need any of that stuff. Okay, so the code becomes way more simplified actually than expected, right? Just measuring thing is not particularly difficult to do. And on top of that, I completely forgot, since we're measuring things, we don't need to render it, so we don't need the renderer. It becomes even more simple, right? So it becomes even more simple. Okay, so I completely forgot about that. But the compiler told me, because I'm using statically typed compiled language. And now I have to go through all of these calls yet again, because I need to remove the renders from them, right? Because we don't accept the renderer anymore. But that's fine. I'm just following the compilation errors, nothing more. It's just a compiler-assisted refactoring. That's it. There was not that many of them anyway, right? So that was totally fine. And as with any compiler-assisted refactoring, it just works even though I like split the function in two. Right, I move the functionality from one place to another one, I follow the compilation errors, and it still works, because if it compiles, it works. That's right. If it compiles, it works. That's the beauty of statically typed compiled languages. All right. Okay, go. And just to mimic a fraction of this power, JavaScript programmers had to invent an entire TypeScript. Just a fraction of that power. Anyways. Anyways. So let me do. So should I actually, compile whatever I have already? I think I should before I go and just like start implementing the keyword highlighting. I think I need to commit whatever I have. So we're gonna do introduce shader for text, right? So this is a shader for text. I'm gonna push that right into the repo. The repo should be available for everyone. Okay, good. So this one is rather interesting. So let's find editor renderer, right? Editor renderer. So here we are rendering the selection. We're gonna leave it as it is. It's not really that interesting. And here we're rendering the text. And this is where we have to do all of that interesting magic that I was talking about. So let's see what kind of word, what kind of keyword I want to highlight for now. So let's actually highlight something like for loop, right? So the keyword for. So we probably, for a text editor, you probably have to use some sort of like a sophisticated data structure or some sort of sophisticated method, and you probably need to read some, scientific white papers and stuff like that. We're gonna go with a very dumb solution, right? So I'm gonna implement whatever dumb shit comes into my head and see how it works, right? And see how it works. And then see like in what situations it is slow, and I'm gonna try to optimize that, depending on how we are doing things, right? So we're gonna go off of the an actual real world data. So what kind of dumb solution I'm going to implement? I suppose as we render everything by lines, right, I'm basically each iteration of this loop is a single line that we're rendering. We can take this line and we can try to find this keyword within that line. Where does this thing basically start, right? Where does it start? And render the keyword there, essentially. Right. So interestingly, we can actually render a line, right? So we can specify, okay, so here is the characters, just to render that line. And it renders and it actually moves sort of the cursor on the screen to that specific position. We can do that iteratively, right? So essentially, we're going to try to find where the keyword starts, and then we're going to render everything with white up until that place. Then we render that keyword with whatever color we pick for the keywords, and then we're going to repeat this process, right? Then we're going to repeat this process, finding the next keyword and the next keyword and the next keyword and so on and so forth, right? So, and this is going to work for like a single keyword, right? For a single keyword. Then once we have that for a single keyword, we can easily extend that for several keywords, right? For several keywords. And then as we have that, we can extend that to things that are not keywords, that have some logic behind them. For instance, like comments and string literals and stuff like that. Right, we're gonna go with this kind of approach. We'll see how it goes. Maybe we'll see an opportunity to use some of these fancy data structures, right? I remember, like, there is a lot of data structures that are invented for quickly finding substring within the string, right? We'll see, maybe we'll be able to use something and maybe even measure how greatly that improves the frame rate of the text editor. But for now, I don't really want to go into, don't want to jump right away into sophisticated data structure, because that way I will never implement something that is working. Okay, so we've got another sub from Banukamax. I hope I pronounced your nickname correctly. Thank you so much for tier 1 subscription. Thank you. All right, so so how can we find that substring? So editor has a continuous array of characters, right? So, and we need to be able to actually start searching from within that array. So, and that's a very interesting question. So we only have indices, right? So we only have indices, and essentially we have to start searching, starting from that specific index. I'm just thinking how we're gonna go about that. So this is a loop that iterates through the rows. And here we're gonna have another one that iterates through the characters. So what I'm thinking is that maybe we're gonna have some sort of a cursor, right, that starts at the beginning of the line, right? So it starts at the beginning of the line, and the loop that we're operating on is going to go until, like, while cursor is less or equal to the end of the line, right? So that's basically what we have in here. So here we just compute the end and stuff like that. So I think I'm gonna just wrap this thing like so. There we go. So here is the loop. Here is the loop. And now, knowing all of that, we need to find up until the end of the line where the keyword starts, if it starts at all, right? If it starts anywhere at all. So maybe we need to have some sort of a function, right? We need to have some sort of a function. I'm not really sure how to call such function, but it's going to accept the line, right? Then where do we start within the line, right? So this is going to be the start. And what is the word we're looking for, right? So the substring. And I suppose this thing is going to return the -1 if we couldn't find anything, or the index where we found this thing. So that's going to be this stuff. Interestingly, so since this is a line, right, so this is the index. So this is the pair of indices. We need to also have the data from within which we're like searching all of that stuff. We can either pass the editor itself, right, because within the editor then we can access the data, and then we can do things like line, what is it? Line begin and line start. So this is what we can do. I also don't really know how to call this function, right? So it's probably going to be something like editor line index, right? Editor line index. Interestingly, if we're passing the editor itself, maybe instead of passing the line, we have to pass the index of the line, the row, because we can always find that line by doing something like that, right? So we already have that line in here, right? So here is the line, right? And because of that, we can pass a column in here, right? Okay, that's actually very cool, right? So here's the row, here's the column, and until the end of the line, do we even have this substring anywhere? Right, so that's actually a reasonable design of this API call, I think. Right, and this is what we'll try to find in here, right? So I'm going to say it's not implemented yet. So I just wasn't sure like how exactly I'm going to abstract this separation out. Right, and since this is the cursor, maybe instead of being a cursor in here, let's actually say that it's a column. Yeah, so I think that kind of makes sense. It's a column, right? And while column line begin plus column is less or equal than that, we're gonna keep doing this thing where we're trying to find the index. Editor line index. Here's the editor. We know the row. We know the column. And what we're looking for the keyword, right? So yeah, I'll call it key. Maybe I should call it a keyword, right? Let's call it keyword. There we go. And essentially what we're doing here, right? So there will be two situations. It's when index is less than 0. In that case, we have to render everything until the end of the line, right? Right. And then here, what do we have to do? We have to render until index and then keyword, and then the keyword, right? Something like this. Maybe there is a simpler way to do all of that. Maybe. Maybe we can collect all of the keywords first. But collecting is basically going to be this. You know, collecting all the keywords is basically going to be this process anyway. Right? It's going to be this process anyway. It's just like we're combining that with the rendering. So maybe that's going to be fine. Okay, let's actually start with everything until the end of the line. So for now, this entire thing is just not implemented. But let's actually comment it out. So it's going to be considered implemented, but it's always going to return -1, which means that it's always going to render up until the end of the line, right? So, and here we're actually rendering from the beginning plus the column, right? Plus the column. And here is the size, but it's also minus column, right? So this is like the cursor that we use to render all of that. Okay, and I think that's basically it. And as soon as we render this entire thing up until the end, we have to, I suppose, add like how much we rendered in here, right? So, and the amount of stuff that we rendered in here is this, if I'm not mistaken, but that's kind of weird because it is going to end up, right, so it's gonna get rid of that, which is, yeah, so, I mean, that makes sense, I suppose. That makes sense, I suppose. All right, so let's actually see if it's going to work, right? So this thing is not implemented, but it's fine because this thing is not implemented either, right? So let's go in here. It's kind of a dumb way of implementing all of that, I know that, but it's also intentional, right? I'm implementing things in a very dumb way, basically intentionally, because I'm exploring. Yeah. I'm exploring how all of that is going to go. Right, and if I try to run this entire thing and something horrible has happened. Oh no, oh no, oh no, oh no. Kill, 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 kill. Alright, so, and it's not... Oh my god. Okay, 21. Did it kill it? Okay, so it killed it. Alright, so what happened? What happened in here? That's very, very interesting. So, essentially, this thing apparently never happened, right? This thing apparently never happened. Which is really weird. Yeah, so it basically stayed at equal. Right. So it basically stayed at equal. Maybe we have to actually change this condition to this. Right. Yeah. As soon as we reach that place, yeah, I think it makes sense. Yeah. God damn it. Kill all. I forgot to rebuild. Okay, so let's do it like that, and let's rerun it. So that should work, I think. Okay, so that seems to be working, and yeah. So the rendering is not broken, right? The rendering is not broken. How are we going to be approaching this thing? How are we going to approaching this thing? This one is interesting. So we know where this entire thing starts, right? So what we have to do, we have to render everything up until that point, right? So essentially we're rendering starting from the column, right? We're rendering starting from the column, but we're also rendering a certain amount of those things, which is the size of the keyword, right? So it's basically strlen keyword. We're like rendering this amount of stuff. No, not really. We are rendering. So we've got this thing, right? Here's the column, and somewhere here we found an index, right? So this is where all of that starts. So that means we have to render everything up until here, which means that we're rendering index minus column, right? So this is how much we're rendering. We're starting from the column, and this is the index minus column. Okay. So this is the index minus column. After that, I'm incrementing the column by what? By index minus column, or maybe I can just set it to index, right? So this is where it starts. This is where it all starts. Okay, so, and the next thing I need to do, I need to again render this thing, but this time I'm rendering strlen of keyword. And what I'm rendering, in fact, well, I mean, I'm actually rendering the keyword, but the keyword contains the same characters as we have in here, so it doesn't really matter where exactly we're reading that from, so that should be fine. Right, so then I can do strlen keyword, right, and maybe it makes sense to actually like do something like keyword len, right, keyword, let's put it this way, len strlen keyword len. Okay, and then we increment that, and we have to render that with a different color. Let's actually render that with yellow. I think this is how we do yellow. It's a red and green, right? So because I personally use like yellow in here, so I want to kind of use a similar scheme in here as well. Right, so that's basically the entire process, hopefully. Right, the only thing we need to do in here is to implement the line index, the thing that searches for that keyword within the line, right, and tells us whether we can find that. Right, so we're gonna do int, which is index. It starts from 0, right? And what we're gonna be doing in here, we're gonna be iterating. So maybe I first need to grab the line on which line all of that is located, right? So this is basically lines at row, right? So we're doing that. And what we need to do in here, we need to iterate, right? Starting from column, actually. So column is already set in here. So maybe we can just like use this thing. Yeah, we can just use this thing, right? So column is already set, while column is less than line end, right? So because end also includes the new line, and we don't really care about that new line. And this is plus plus column, right? And starting from here, we can just see whether we match the string. So maybe I'm also gonna have something like size t sub strlen sub str, right? So that way we kind of know. And here we can essentially just see. Man, it would be kind of nice if I could. Yeah, in Go there is a very cool feature where you can mark a certain loop with the label, right? And then you can have like a nested loop, and then you can say, okay, continue continue that specific loop or something like that. That would have been really convenient right in here, but unfortunately we're programming in C. And C is not that good of a language. It's not particularly modern language, let's put it this way. All right, so let's start like this. And we're gonna be iterating a substring len, right? Something like that. And we have to do that while column plus I is also less than the line end, right? So we have to do it like that. Maybe, right. And essentially, if sub str I is not equal to the line, this one is complicated, right? So we have to do line data items, right? And we actually start from the line begin, so this is where we start, plus the column plus I, right? So we're just iterating it like that. And if it's not equal, right, I would love to just do continue again. That would have been actually super convenient. Right, that would have been super convenient. And it also basically means, right, it basically means that this thing has to be separated, like in C at least, into a separate procedure, right? Has to be separated into, you know, moved into a separate procedure, so we can do this kind of stuff. Okay. So let me see, how can we approach all of that stuff? How can we approach all of that stuff? It's kind of, it has to be probably Boolean, right? Editor line starts with, probably, right? Something like that. Starts with, where we provide the editor, the row, and the column. Right, so this is the row where all of that starts, and then the column from which we're doing all of that, right? Something like that. And we also need to accept this thing. So I think it has to be called prefix, right? So it has to be called prefix. So let's actually move this entire stuff in here. So prefix len, it's going to be size t, prefix len, str len, prefix. Prefix len. Okay, so we're iterating from the prefix len, then column plus I line, so we have to have that line somewhere in here, so let's also put it in here as well. And if this thing is not equal to what we expect, to the prefix, we instantly return false. Otherwise, we may return true, but only if we actually went through all of the characters of the prefix, meaning that I is greater or equal than the prefix length, but I is not visible in this particular scope, so we have to kind of move this outside in here, right? Something like that. So then we can check it in here, right? So then here I'm just like iterating through this entire stuff, making sure that I'm not going. So because you can try to check it, you know, too close to the end of the line where prefix doesn't fit anymore, right? You know what I mean? So because of that, it's kind of, we can actually kind of try to check that up front, meaning that if column plus the length of the prefix, right? The length of the prefix is too big, right? Then instantly return false, like so. So that way you simply always return true in here, and you never have to, yeah, so you can just keep it like that. And because you already checked that condition up front, you never have to check it in here. Maybe that's a good idea, right? But I'm not really sure if this has to be equal or not. So that's kind of interesting. So essentially, all right, so we have something like this, and this is the new line. Right, 0, 1, 2, 3, 4, 5, and then new line is 6. I'm going to denote the new line with n. Right, and essentially here. So imagine that the prefix is 4 characters. So I do 3 plus 4, 3 plus 4, and it becomes 7, which is kind of weird, right? So I think it has to be something like -1, right? So because what I care about is the last character of that prefix. If the prefix is 4, I know that the last character is going to end up on the new line, and this is what I'm checking for in here, right? This is what I'm checking for in here, and because of that, I think I have to do -1. Right, that's basically what it is. So, but interestingly, we may have a situation when the prefix len is 0, for instance, right? So, yeah, what if you literally try to check if this thing is, yeah, with an empty string? What if you put empty string in there? All right, in that case, I think it makes sense to check the following thing. If the prefix len is equal to 0, just instantly return true, because, I mean, empty thing is always like a prefix of that, if you know what I mean. Right, so I think we checked for everything, right? So if it's 0, it's always true. Then we take the length, and if the prefix goes too much outside of the line, it's instantly false, right? So that's not the prefix we're looking for. And in here, so if it's not equal, it's instantly false. And if we manage to went through all of these, you know, checks, if we manage to went through all of that, it is instantly true, right? So that means it in fact starts with this entire thing. So, all right, that's pretty cool. So we have a function that just checks whether a certain thing starts with, given also a column, right? Which is nice, right? So column is already set, and we're iterating all of that. And I already forgot what I was doing in this specific place. Right? Editor line starts with e row column substring. If this entire thing starts with that substring, we can instantly return just column, I suppose, right? And because of that, we don't need an index, right? So because we're directly operating on the column. All right. Okay, and then here I just return -1. Okay, that's beautiful. That's beautiful. All right. That is very, very cool. So isn't that pogue? Isn't that pogue? I think it's pretty freaking pogue. All right. So let me go one more time through this entire stuff, right? So here's the substring length, and we don't really need substring length anymore because it's only needed inside of this function, right? So that simplifies everything dramatically. Right, so we're starting with a column. We're iterating up until the end. We don't really care about the last character, right? Because it's a new line. We're not rendering, whatever. Right, and then we're checking whether the line starts with this thing starting from this specific column, and if it does, we just return the column, converting it to a signed integer, and it's signed because it can be a negative, and negative indicates that we couldn't find anything. We went through this entire stuff, we couldn't find anything, and that's basically it. All right, so how do we check whether a certain thing starts with the prefix? Right, if the prefix is 0, we can always say that it starts with 0 prefix. Anything starts with a 0 prefix. How does it play with this thing? If we're trying to use, it basically will always return you the beginning of the line, right? So that's fine. That's totally fine. Okay, so then if the prefix is too long and it goes outside of the line, it's instantly false. There's nothing to check in here. Okay, so we're iterating through each individual character of the prefix, right? And we're checking it starting from the beginning of the line plus the current column, right? So it's offset plus I. Okay, that's totally fine. Right, and if it's not equal, at least one character not equal, it's instantly false. If we went through this entire loop, it's true. That means we do start with all of that. Okay, so all of that, I don't see any like glaring mistakes in here, any glaring mistakes, so that should work, right? So then like in here we're finding an index, and if we found an index, we just basically split the rendering into two parts. We first render the thing before the keyword, then the keyword, and then we repeat the process one more time. Okay, I guess that's it. So that's how we render at least a single keyword. Right, the algorithm is linear, right? So, and it's dumb, and it's done so intentionally, right? Just to get the idea what exactly we're trying to do in here. Okay, so here is the row, because it's supposed to be items, right? So we can't usually do it. Okay, so let me actually just build without trying to run the editor, right? Because we might have made a huge mistake that will kill my entire laptop. So we have to be super careful in here. Okay, so at least everything compiles in here, right? So this is a very finicky process, right? So I have to be super careful in here. And, okay, so, okay, the rendering is not broken. The rendering is not broken. We're about to type 4. Isn't that cool? Isn't that cool? Oh! We have a freaking highlighting. Holy shit. Look at that shit. It's dumb. It is dumb. It's linear. It is absolutely dumb. I do understand that. I do that intentionally. Now we kind of know the use case for our entire sort of like highlighter and whatnot. So yeah. It would be also nice to maybe highlight things like ifs, right? So this one has to be maybe like J. So we have like a general dumb mechanism where we can just put like a keyword, and that keyword is going to be highlighted. It is slow, but we have something working. We have a slow working mechanism that then we can try to optimize, right? So again, we're searching for substrings linearly. But there is a tons of algorithms that allow you to search within the substring way faster with a little bit of pre-calculation. But I mean, it's just a matter of just getting one of the data structures and algorithm and just using it in there, right? But we already outlined what exactly do we want. All right, so let me see. We're only highlighting one keyword. What if we have several keywords? Right, what if we have several keywords? Well, we have to add another dimension to this loop, right? So we have one dimension that iterates horizontally on the current line. We need another dimension that then tries the same thing for each individual keyword. Again, it's going to be slow, it's quadratic, right? But it's a start. At least it is a start, right? So let's say, okay, we're going to have keywords. We're going to have 2 of them. The second one is going to be if, right? So this is the second one. And in here, right, so the keyword length, we don't even need a keyword length. Well, we do use keyword length, that's fine. Right. So, and now, let me actually do something like this. Can I do something like keywords count? Size T, key words count is going to be 2 for now, right? And essentially, what do we do? Right, we have an index -1, right? Index -1. And then we just iterate through each individual keyword, right? So this is the keyword. Maybe we can even do something like char keyword. Yeah, keyword null, and keyword length is 0, and then the index, and this is more of like a keyword index. Let's call it a keyword index. So we're iterating through the keywords. Keyword count, keywords count, plus I, right. And then we do keyword index. Okay, if keyword index is actually greater or equal than 0, that means we found it, right? So that means we found it. We have to do keyword equal to keywords I, so that's that, and then keyword length is keyword. The length of this thing is len. and then we have to break out of the loop, right? So we're just checking whether the thing starts with one of the keywords, right? So something like this. This one is actually kind of bad, right? So it's not scalable. It's not scalable at all, right? It is not scalable at all. You know why? You know why? Because you may find the first keyword further away, right, than another one, right? So maybe you have a situation, okay, you first checked for 4, but you have something like some text, right, 4, and you have if somewhere here. You have if somewhere here, right? So since you're checking for 4, you instantly found these 4, so you're gonna render everything with white, and only then with that. So it's not going to work. So we need a completely different approach. So this approach doesn't scale, right? It doesn't scale the way that I expected. But we already have a thing that can check whether a certain line starts with a prefix. What if we render character by character? Okay, so essentially we have the current column, right? We have the current column and we can check, okay, the line from that specific column, does it start with any of the keywords? Does it start with any of the keyword? If it does, we render that keyword and we look again. Does it start with any of the keyword? It doesn't, we just render that single character as white. You may then ask, isn't that going to be slow? In a sense that like rendering several characters, like character by character, is going to be slower than rendering a bunch of them. The answer is no, because when you render a character with our renderer, you're actually pushing vertices into the buffer. You're pushing the vertices into the buffer, and they're actually rendered only at here. In reality, whatever you do in here is never rendered until you hit this place. Everything you do in here is buffered anyway. It doesn't really matter if we're buffering by one character in here. It's buffered by one character inside of this function anyway, so it doesn't matter. So I think that is going to work out, and we will have something interesting. Right, so, and that solution may work. And what's interesting is that we already implemented the function that can check whether something starts with a particular string. Here it is. It's not like we have to scrap everything and start over. No, we already have part of the solution that are usable in here. It's just like we don't need this function anymore, which is kind of cool. Like, remember how I was complaining that I have to separate this thing into 2 functions just because I don't have this ability like in Go? It was actually turned out to be useful because like the only part I need right now is the thing that I separated in the first place. That's actually kind of interesting. Don't you think? I think that's kind of interesting. Like, yeah, would it be like, you know, obvious to me if I didn't separate it into a separate function? That's actually rather interesting. That's actually kind of cool. All right, anyway. Maybe I should make a small break because I kind of have a dry throat, so I need to maybe make another cup of tea. So yeah, let's make a small break, and after the break, we're gonna try to make a solution that is more scalable than whatever I came up with at first. You know, we're doing that iteratively, right? We're doing that iteratively. We're gathering all of that information as we go, right? So it's kind of difficult to just like, you know, wrap my head around this stuff until I actually tried it and gather some information. Anyway, let's make a small break and... All right, so I just realized a very interesting thing. I already said it on the break. So the approach that we currently use is not going to work for when the keywords are like inside of the word, right? For example, the word forward, right? As you can see, the 4 is highlighted in here, which is not particularly correct. So essentially, I think a better solution would be to like literally tokenize the text, but you'll probably have to have like a separate tokenizer per language, right? Depending on the language, you would tokenize that thing differently. But that is already like kind of a topic for another stream, right? This is a topic for another stream. And on today's stream, I'm gonna finish the like a substring solution, right? So I'm gonna finish the idea that I already got. And on the next stream, we should be able to actually try and go ahead and implement like a tokenizer for C. I actually never implemented tokenizer for C, specifically for C. I think it's going to be kind of interesting, right? So I implemented tokenizer before, like a lot of tokenizers for different kind of like languages and stuff like that. But specifically for C, that will be really interesting, right? And we'll probably have to also implement some infrastructure to make it work with different languages, right? So maybe have different tokenizers depending on the language. So that means we'll have to have like different language modes, right? We're getting into very interesting rabbit hole. Very interesting rabbit hole, I gotta say. Anyway, so essentially what I want to do, I want to implement this idea where I just have a bunch of keywords, right? So, and I'm starting to render a particular row starting from a column, right? So I'm rendering from a column. And the first thing I want to do, I'm going through the keywords, right? Going through the keywords, and I'm checking if the current line starts with any of the keywords, right? So starts with, right? So here's an editor. I think we have to do an editor, right? So yeah, it is an editor. So we know the row, we know the column, and now we also have a keyword, right? Keywords I. There we go. There we go. What the fuck am I doing? What's going on, Emacs? Okay, so if this thing starts with that specific keyword, if it starts with that specific keyword, we just want to render that keyword, right? So it's as simple as that. To render that keyword, what do we have to do? I think this is literally what we have to do. I'm pretty sure. So that's what we do. Begin column keyword, right? So then we render that and we increment the this thing with the keyword. And after that, I would like to go to the next thing in here, right? So I would like to do something like continue next. But maybe that's fine. Maybe it should be enough to just break out of that loop. Yeah, I think that's it. Right, so just break out of that loop. But it doesn't. We'll have to extract all of that to a separate function as well at some point. Yeah, that's for sure. So essentially, I feel like we need to have something like starts with one off, right? Starts with one off, where I could do something like, right, I provide the keywords and keywords count, right? And then I get the keyword. So I literally get a pointer to the keyword. Then I can say, okay, if keyword is not null, right? If it's not null, I'll just render that specific keyword. Okay, that makes sense. So we don't need that stuff in here. Right. Otherwise, if it doesn't start with any of the keyword, I can just like render a single character and increment column by one. Render single character and just column +1, and that's going to be it, right? So how can I render a single character? That's a very interesting question. So this is a column and just one actually. And then I'm just thinking I can probably abstract that away somehow. Right, because the only difference between these two branches is the length and the color. That's kind of cool. So these two branches are compressible, but I'm not sure if it's worth it actually. I'm really not sure if it's worth it. And this one is not really needed anymore, right? So yeah, that's cool. It's kind of cool, isn't it? Yeah, it's actually turned out to be simpler. Okay, editor line starts with the one off, and we basically provide several prefixes. Is that the plural of prefix? I don't know. Right. So this is arguments. Okay. These are arguments. So this is prefix. What's the plural prefix? Prefixes. Plural of prefix. Prefixes. Okay, I was right. So, and the amount of those things is going to be count. Okay. So, and in here we're gonna have a character. Though this thing has to be like a pointer to pointer, right? I'm pretty sure. So let's give it a try. Initially it's going to be equal to 0. And essentially what we do is just like a size less than prefixes count plus I, and then we just reuse this function, right? We just reuse this function. This one is E, right? Then this, and then prefixes I, and if it is true, we simply return this thing. Otherwise, we return null. Look how simple is that. This function is not needed anymore, right? So it starts with one of those things. Okay, Sina Basil, thank you so much for 6 months of tier 1 subscription with the message howdy. Hello, really glad to see you. Are you the Basil from the Discord server? Hello, really glad to see you. All right, so what we got? Yeah, that should be it actually. I think that should be it. So in that way, it will just pick one of the keywords. It may become a problem when so we have 2 keywords and one is sort of like a substring of another one, but I think in C it doesn't really happen that often. Right, so let's actually try to recompile this entire thing. Right, so let's go to the compilation errors, compiler assisted refactoring. You know the drill. Okay, so here's the keyword, and we can do a keyword length size t. It's a strlen keyword. Okay, okay, compiles, and it works. And if I put 4, it also highlights. So that means I can now organize a loop. So for example, we have rows, and let's say that we're gonna have 10 rows. So this is the first thing, and then we have columns. Right, we're gonna have also 10 columns, plus columns. And depending on whether the sum works, row plus column, is even or not, we're gonna draw the cell with different color, right? Equal to 0. If it's even, right, something like, we don't have indentation in the text editor. All right, so board row column is going to be red, something like that. So, and that creates like a checkered pattern or something like that. And yeah, so with the current mechanism, it should be easy to add more keywords, right, in the future. We can try to open maybe the source code of this thing, right, and just go down. Yeah, this is literally the example I was actually given. Yeah, forward. Yeah, that's exactly what I'm talking about. Right, so here's the if, for instance. You can see if we can have 4 and stuff like that. So that's actually pretty cool. Right, so now we can probably take the list of like existing keywords of C and just put them in there and see how it goes. All right, so keywords, where are the keywords? Keywords. So let me super quickly make this a global thing, because it will make it super easy for me to do something like keywords count, which is size of keywords divided by size of keywords 0. There we go. So that automatically computes the size of this entire thing. And now I'm gonna go to the SimpC mod, right? So the mod that I developed some time ago for my Emacs, right? So I'm using actually custom C mod, right? And here are all of the keywords that are supported in there, right? So they also include the C++ keywords, in fact. So the thing I want to do now, I want to just like put it in here and do something like that. I can't. I just simply can't. Okay, it's kind of weird, but... Oh, and also, okay, so I probably have to do something like query replace quote space quote replace with quote comma quote, and hope that I can separate everything properly. Okay, so I guess that's fine, right? So that's a fine indentation, right? It's a fine indentation. So we're gonna try to recompile. Oh my god. Okay, so we probably should get rid of this thing, right? So we're not gonna specify any size of the array. And now, if I try to open this thing, so include doesn't really work, but if I do int main void, right? So then I can do return. Return doesn't work, really? Are you freaking serious, my dude? Where is return? It doesn't work. Oh, is that because of that or because why? So it's something is fishy in here. As you can see, int works, for works, if works, return simply doesn't work. I have no idea why. So yeah, ret. Probably because of one of those things, but it's kind of sus, not gonna lie. So if I put co-return or works, but this one doesn't work. So that's really weird. Co-return doesn't work as well. Huh. Is that because maybe... Okay, so here's the return. So if I use register, register doesn't work either. What about long? Long seems to be working. So I suppose everything after that... No, catch works. At the end of the line there's no comma, but I don't think it matters. Oh, maybe... Oh, okay. Oh yeah, it does in fact matter. Goddamn C! And it's stupid multi-component string literals. Oh my god, thank you so much, yeah. Because in C, this stupid shit is considered a single string literal. This is a single string literal. It's a single one. Yes. God damn it. Like, and after that, people come to my comment section and saying that they lose respect for me because I shed on C. Like, I don't have to shed on C. C sheds itself. Anyway, thank you so much. I'm joking. Don't worry, I hate all of the languages equally. Alright, so what do we have? Yeah, return works. And then I can do printf. I love this way. Maybe I should leave it like that. I really like that. Look at that. Look at that. That's an epic syntax highlighting. And we just gathered some information. This is like, people may say, oh, this is so stupid. Why are you making such a stupid things? But by doing stupid things, you gather information, and this is a very good demonstration why you have to implement the tokenization, right? So it actually shows really well why tokenization is important. Like, it's just like, yeah, this is a good example. Yeah, that's why you have to do tokenization. And it's extremely educational, and that's precisely why I'm doing that. I'm gathering information. I'm gathering information and I'm demonstrating all that. So there's also a very interesting bug. I'm not sure if you can see that, but there's sort of like a faint line. Yeah. You can kind of see that there is like a faint line in here between the glyphs and stuff like that. So, and maybe this is because the glyphs are packed too tightly. Oh, yeah. So you can clearly see that in here, right? Yeah. So there's a little bit of this stuff going on. So maybe we have to put a little bit of padding between the glyphs and whatnot. Yeah. So the thing I'm gonna do, I'm gonna do a committee and maybe even a pushy, and I'm gonna call it a day. So yeah, we implemented a very dumb, very straightforward syntax highlighting, and that helped us to gather information about how we have to do that properly. So what we have to do instead, we have to implement a tokenizer, right? So essentially we have to take the text, we have to tokenize it, and by tokenizing I mean grouping the characters into certain groups and marking those groups to a certain category. That's what tokenization means. And then we can assign different colors to different tokens, right? And since I already done tokenization multiple times, I think it should be pretty straightforward for me. But that requires like probably introducing like a whole module to the system, right? A whole translation unit that accepts the text and tokenizes. You know what? Maybe no. STB libraries, right? The STB libraries that I use all the time, right? So the STB image and stuff like that. One of the libraries that we have in here are actually kind of cool. Look at that. A freaking CLexer. I swear to God, STB libraries, they have like a library for literally everything. Like, I need a CLexer. Like, here you go. It has a CLexer. I don't know why, but it has it. Maybe for some sort of a code generation, right? Maybe for the situations when the game developers really like to have like a file with different structures, and then they like to have a preprocessor that takes those files of structures and generates serializes and deserializes of these things. So, and they usually use like a limited syntax of C within those files, and maybe that's what it's used for, like to implement like automatic serialization, deserialization for structures and stuff like that. You know, the game developers really like to do this kind of stuff, and that's the reason why Jai was created, so to build that into the Jai. Right, so, but we can try to use this thing. We can try to use this thing, but I'm not sure if it's a really great idea to use it, because for different languages we'll need to have different tokenizers anyway, right? So it's just like we have a tokenizer for C, but where can we have a similar tokenizer for JavaScript or for Haskell? Like, none of these tokenizers are like as readily available as this thing. So we'll have to still come up with our own thing. And maybe for just syntax highlighting, we don't really need an entire tokenizer of C, because the tokenizer of C might be more complicated than we need for just highlighting. You know what I mean? We'll see. Maybe we're gonna have like our small simplified tokenizer instead, specifically for highlighting. Anyway, so implement simple syntax highlighting based on matching substrings, right? It demonstrates really well that we have to properly tokenize the source code instead, but we will do that later, and we'll push that right into the repo. How about that? And we still have a rainbowish thingy. It would be kind of cool to maybe highlight certain things with these kind of effects. Yeah, that would be kind of cool. Oh, by the way, let's actually open the source code of the text editor itself. Freaking, this makes me laugh every time. I love it. Okay. Oh, look at that. Look at that. Oh, that's so good. Now that's what I call syntax highlighting. Holy shit. Holy shit. That's so cool. Mr. Zorin, how does, for example, Vim know what words are keywords? I don't know how exactly Vim does that, but I personally would do that the same way as the compiler knows what is a keyword. Because, I mean, compiler knows what is a keyword. So, compiler is a program written by humans like me, right? I'm having a little bit of a Zuckerberg vibes. So the compilers are written by humans like me, so that means it is possible to write a program that can distinguish keywords from non-keywords. So I'm gonna follow the path of my fellow humans. Cheers for humanity. In the meantime, the compiler was written by ChatGPT. All right. So that's pretty cool. All right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and let's rate somebody. So, is anyone streaming anything epic on twitch.television? Forsen. Is Forsen ever streams anything on science and technology? I mean, on software and game development section? I'm actually not sure. I think he doesn't. I didn't see anyone who I follow streaming anything. So how am I supposed to raid? Where are my fellow humans? Where are my fellow humans? Anyway, I don't see anyone. Alright. That's it for today. Thanks everyone for watching. Hope today's stream was educational as it was entertaining, and love you.